Hi. So I'll start. So I'm Rajesh. I'm segment leader for critical infrastructure communication business for Southeast Asia with G Varnava, and I'll be giving idea on the smart city segment of this technology, Nessum technology. Specifically, a bit about the context of India, and then coming to basically the challenges, the solutions, what are the communication requirements, and what are the solutions based. Uh, in the conclusion, I'll also share some of the references of the use cases and what kind of services are implemented. Uh, so so if you see, so typically, let me just put this a bit. Yeah. Okay. So this is the smart city concept typically for India. And on the left hand side, if you see, so this is the government of India's key drivers why this whole program of smart city came up. Incidentally, in India, there are approximately 120 smart city projects which are in various phases of implementation as on date. But if we look at the applications, so briefly, very briefly, so parking management system, traffic light controls, waste management, energy management, and power management, plus a number of other applications which have been discussed by my other co-panelists, like in educational institutions, apartments, basically with the intent to have a seamless communication system, which has not only cost competitive but highly reliable. So this is the overall concept uh, for government given by the government of India, and the complete various modules of the smart cities are in India are built around these blocks. So we can say these are the building blocks and also the applications. If I go to the next slide, uh, I do not think I'm not able to go. So one sec, please. Yeah. So here I am. Okay. So part of it I have already covered, right? So public services, transportation, public safety, then integrated smart functions, infrastructure. All of these are the cases which are being implemented in the multiple smart cities. Uh, and basically, the prime application, except for surveillance system, which is a high bandwidth requirement, is mostly a low bandwidth requirement at a shorter distances which are about anything between 200 300 meters to about 2 to 2.5 kilometers, except for surveillance system which has a high throughput requirement of going into some 7 to 8 mbps per surveillance system camera. And the networks are built around the three phases are networks, the connectivity, and integration of the data, and the source is a open source, so that uh, uh, because there are different modules, so at end of the day at a data center, all of them can be controlled, can be managed, monitored, and any remote operations can be done from there. So this is a perspective from the smart city point of view. Now we will be moving to the technology part. So, so let's start with the requirements for the communication requirements. So basically, on the functional side, uh, this value proposition, what we have of PLC is this offers a communication on a low voltage and medium voltage power lines. So it totally does away with any kind of a fiber and its associated or wireless and its associated costs and complexities. In case of fiber, if it is an underground fiber, so trenching has to be done. For overhead, then again, it's very difficult to do in the cities. Then extended connectivity. There's firstly, there's no fiber required, and neither there is any frequency band permissions for the spectrum, that is license required from Department of Telecommunication. So that is not required. There is no requirement for a dedicated DC supply. Mostly the radios and the optical equipments, they work on minus 48 volt DC supply. But this equipments based upon the Nessum technology, they work on 220 volt supply, which is available at most of the places. And like in radios, we have a big challenge of line of sight, spectrum availability, and for fiber, right of way. Right of way is like permission to make the trenches, and then the laying. So uh, these are some of the functional aspects which this PLCs with this Nessum technology they address. And if we come to the commercial side, so typically what we have seen in discussion with the multiple distribution companies and smart cities and mines and industries also, is that if they're going on an optical technology, then approximately 60% of the cost only goes into the fiber, and balance is on the equipment side. So in with this technology, there's a huge saving for them, apart from the complexities and the maintenance. So the capex itself is reduced by almost 50% minimum. Second is if option of there's always an option to go with wireless, but then in wireless there are three challenges. The biggest challenge is availability of the frequencies, because in a city environment, it's not possible to operate on a licensed tree band because of so much of interference is there. So there's a huge payout which goes year over year to the government, that is Department of Telecommunication, which has to be paid. And then again, it has to be checked what frequency bands are available for use. Then there is also a cost for putting up the antennas and the towers, which will be put on some commercial establishment or residential, places, for which a monthly payout towards the rental goes. Then there has to be a dedicated power supply arrangement has to be done, and then any kind of a lease bandwidth charges or some subscription. By the way, I'll just I like to emphasize here that in discussion with our customers, what we have found is that on a lease bandwidth, the availability which they are able to get is just about 90%. 90%. So, which is actually not sufficient for such mission critical applications. So that again is a big challenge. And above 3 points, if you see, so there's a massive saving also on the operation and maintenance, because there's no fiber cuts, there are no interferences, and one of the challenges with the wireless communication also is that once at a time of planning, when we do a planning, there may not be any building which has come, which interferes with the path on which the RF signal propagates. But 1 year down the line, or sometimes in 6 months or even 8 months time frame, some building can come, some other construction can come, which then again one has to redo the complete engineering and realign the things. So basically, the value proposition lies on the leveraging of this Nessum technology for higher bandwidth and reliability, and like I said, leveraging them with the product development, engineering, and having a proper coupling arrangement to couple the signal from these this technology equipments to the different voltage levels and different diameters of the power lines. Uh, so this is the value proposition. Now the communication. Yeah.
Rajesh, sorry to interrupt. So 4 minutes to go.
Oh, sure. Fair. So, so in the cost, I have already actually touched upon. So I'm not going to touch this because whether it is fiber or wireless, vis-a-vis them, this technology offers a advantage on the cost. Operational, again, I'm going to skip this one. Maintenance, I'll very quickly touch because in the cities there are so many different agencies working, like sewerage is a different part, power is a different company which is doing, water supply is a different company. So road constructions are happening. So there are repeated cuts on the fiber. So we do away with them with this, and wireless, of course, interference and any kind of a new construction which can disrupt. So these do not allow for a reliable communication. Okay, now coming to the what is the solution. So solution basically offers because we just please focus on the right hand side. So this gives us a better noise immunity. It has a, though these points have been discussed, but it has a more efficient MAC layer and routing protocols to maximize the bandwidth and throughput in the larger networks. Uh, there's an inbuilt mechanism with this technology to handle the interferences. Uh, I discussed about availability, so lower downtime, and also on the security side, so AES 122, 128 encryption is there, and it has a centrally controlled network registration as well as enterprise class cyber security features are available. Uh, Okay, so if you see here, this is how the deployment scenario, and I mean, this is independent of the industry, whether it is industry or a cement plant or a steel plant or it is a, a smart city or a mine or anything. So basically, if it's a underground, so this is a equipment, and these are the couplers which couple on the power lines, and then underground power lines. These are inductive couplers for underground lines. And if we have overhead lines, then there are capacitive couplers are there. Equipment remains same, the port remains same. The only change is in the coupler, and with different voltage and with different diameters, the couplers will change. Couplers will change to adjust to that. And some of the, I think this has already been shared in one of the initial introductions. So this technology supports all possible configuration, whether it is point to point, point to multi-point, or a ring, or a daisy chain. So we can have different permutations and combinations depending upon the customer power lines, and the system can be designed for optimal performance. Okay, I'm coming to my last slide. Some of the cases, we have, by the way, we have a platform at Noida, which is in NCR, close to Delhi, where we have these equipments and where we do the internal testing for latency, throughput, and other kind of simulation. But apart from that, there are field tested performance for data, okay, data on, up to 2 Mbps, which is normally sufficient for any kind of a metering application. Then IP telephony, surveillance system, and remote operation, etc. For NMDC in India, there are almost, I think, close to 40 equipments are working there, and 28 are in one single network. Other 12 are in a separate network. Then Iberdrola, Spain, where we have almost 34 equipments in a ring, and CK and Nice Grid in France. Also, we have implementations in Sweden. So this experience which is coming out is not only based upon the theoretical testings or theoretical calculations or testing in a lab environment, but the performance is coming out from the actual installed bases which we have. To sum up, the technology, Nessum technology, which is so Nessum technology based PLC communication is an extremely reliable communication for small distances, reasonably good bandwidths, and which is very economical, working across various segments and also smart city communication networks. That's all from my side. Thank you very much.